We've seen how SQL Server Integration Services works with Linux. How about PolyBase? Welcome to this video on SQL Server on Linux. My name is Kevin Fiesel, and I'm the proprietor of Galaxy Services LLC, a consulting firm which specializes in work all across the data platform space, especially SQL Server. The last video was a pretty big letdown. I came into it not knowing how well SQL Server Integration Services would work on Linux, and I left quite disappointed. I know that SSIS has already seen its heyday, but the lack of functionality in the product on Linux was rather annoying. Today, we're going to try the same thing, but with PolyBase instead. As usual, let's start things off in the classroom. Alright, let's try to get the taste of disappointment out of our collective mouths and try again with another feature installation from Microsoft. This time it's PolyBase, SQL Server's data virtualization feature. Now, I happen to know a thing or two about PolyBase. I even wrote a book on it. Dozens of people bought it, so they can attest that it actually exists and it has words inside of it, words and pictures. But that book covers PolyBase on SQL Server 2019, and we're living in the days of 2022. Things have changed a bit. I'll leave a link to a presentation that I deliver on data virtualization in SQL Server 2022 if you're interested in seeing what has changed and if you'd like to grab a copy of the scripts that I'm going to use. In the meantime, let me give you a little bit of an overview about the product. PolyBase is Microsoft's solution for data virtualization in SQL Server. The quick idea behind this is, I have data stored in some remote system, such as another SQL Server instance, or an Oracle or Postgres database, Parquet files, CSV files, and Azure Blob Storage, even Excel files. I want to expose these as tables in SQL Server, allowing people to query from them without having to think about where that data actually resides. There's a bit of nuance to consider about possible performance problems, authentication and authorization issues, and the like, but I'm going to pass right over these for the purposes of this video because that's PolyBase, not necessarily PolyBase on Linux. Check out my presentation if you want a deeper dive on those topics. I also have a link to a delivery of it on YouTube, so if you'd like the video form, you get it there. But let's talk about PolyBase and Linux specifically. And I'm going to start with the notes and limitations. The list of limitations is a lot shorter for PolyBase than it was for SSIS, so that's a good start. Looking at this list, we see 3 limitations. The first is that they don't support SQL Server 2017. That's not a big deal, just use 2022 instead. The second is that scale out for Linux is unavailable. That's not a big deal either. Microsoft removed scale-out groups from the product altogether with SQL Server 2022, so it's not in Windows anymore either. The third is that Hadoop is no longer supported on SQL Server 2022, and again, that was also true for Windows. So there's nothing on here that makes me wish I hadn't committed to talking about this product feature in a video. They also have installation instructions for Red Hat, Ubuntu, and SUSE, which is a good sign. If we look at the instructions for installation on Ubuntu, you might panic a little bit because it doesn't say anything about Ubuntu 22.04, but even that's okay. I looked at the package management website for Microsoft on Ubuntu 22.04 and I did see the PolyBase binary, so even this, it's going to work just fine. By the way, there are also installation instructions on installing Hadoop support on Ubuntu and these other distributions. Let me talk really briefly about this. The original use case of PolyBase was to enable SQL Server to communicate with a Hadoop cluster in a way that took advantage of Hadoop's distributed nature. When connecting to a Hadoop cluster, you could have the PolyBase engine build a MapReduce job in Java that would execute on the Hadoop cluster and return data back to SQL Server. Then the PolyBase data movement service would reshape that data in a way that fits SQL Server's needs and allow you to continue processing the results within your instance. Microsoft embedded this technology into a product that they called the Microsoft Analytics Platform System and the SQL Server Parallel Data Warehouse. It was a really clever solution that had the small downside that it came out right about the time that Hadoop's classic form of MapReduce peaked and Spark's in-memory MapReduce operations were already eating its market share. By the time PolyBase came to the SQL Server box product in 2016, Spark was already becoming the dominant force for operation on Hadoop clusters, and the classic form of MapReduce, even with the speed boosts you got from Tez, they just weren't cutting it anymore. In practice, I would imagine that the vast majority of PolyBase customers used that Hadoop integration for one little side effect that came with it. And that side effect is that Azure Blob Storage exposes a web HDFS interface, allowing you to query it as though it were a remote Hadoop cluster. This meant that we could create tables based on data in Azure Blob Storage and expose them in SQL Server as virtual tables. SQL Server 2019 expanded support in the ODBC direction. Basically, if you could connect to a data source with an ODBC driver, there was a pretty decent chance you could get PolyBase to work. Sometimes you had to find just the right ODBC driver, and I did find it kind of finicky once you got off the beaten path, but it did work, and it still does work. With SQL Server 2022, we saw data virtualization move more toward APIs, letting us connect to AWS S3, Azure Blob Storage, Azure Data Lake Storage, and more. This is a lot more flexible than the old Hadoop interface, and getting Hadoop to work required installing Java on SQL Server instances, something a lot of DBAs balked at. So basically, Hadoop support became obsolete and poof, it's gone. I'm kind of sanguine about that because the intersection of companies using SQL Server 2022 and companies using classic MapReduce jobs against Hadoop clusters is, well, there aren't many of them. All right, we've talked enough about history. Let's get to business. We are back in Ubuntu 22.04. Last episode required us to move to Ubuntu 20.04, but fortunately, we're good this time around. To install PolyBase functionality, you first need SQL Server on Linux installed. If you haven't done that, go check out my video on installing SQL Server on Ubuntu 20.04. I'll link to it in the description below. And if I remember to do so, I might even include a link to it, I don't know, right about now. All right, you have Ubuntu, you have SQL Server on Linux installed, and you are raring to go. Installation is pretty straightforward for PolyBase. We're going to install it from the apt repository for Microsoft products. This is going to take a few moments to install, and once it's done, it will tell us to restart SQL Server to enable PolyBase. Let's do that now. Cool, everything's installed. So, what next? Well, what comes next is we need to use it. I'm going to use Azure Data Studio. I've been using SQL Server Management Studio in this series, so I've decided to mix things up just a little bit. Before we get too far here, I'm going to need to connect to my virtual machine's SQL Server instance. I'll open the window to connect and input the IP address. Then the username will be SA, and we'll be connecting via SQL authentication. Add my password and boom, we're in. Now I can run these scripts that are available in the left-hand menu. These scripts came from my data virtualization in SQL Server 2022 talk. Let's start by opening up the script in the 2022 folder called 00 enable polybase.sql. We can see that we'll need to run this from the master database and set a configuration feature called polybase enabled to 1. The other configuration setting around polybase export is something that isn't really that relevant in SQL Server 2022. It was there to allow you to insert data into Hadoop or Azure Blob Storage tables, but PolyBase is now basically read-only as of SQL Server 2022. Kicking off the script, those two ran successfully, and now let's restart SQL Server one more time. I'll run the command to restart SQL Server. It'll take just a moment, and when it's complete, we will be up and going with PolyBase. Or will we? I'm going to show you a couple of insidious problems I ran into along the way here, just in case that you hit any of them in your trials. Let's first open up script 01. This will let us create a Scratch database. Inside that Scratch database, I'll create a master key that is so secure nobody will ever guess it. Next up, let's open the script for Azure Blob Storage. The first thing we do is decrypt the master key, as this will allow me to work with saved secrets in SQL Server. After that, we have the meat of the script. This will let me talk a little bit about the 4 primary items in a PolyBase virtual table. The first one is optional, and that is the database scoped credential. This is how we can securely connect to remote resources. Note that there isn't some kind of user-specific functionality, so you can't have Alice connect using one key and Bob using another if they're both querying the same table. If you really need that, you could hack something together using multiple virtual tables and exposing one to Alice and the other to Bob, but PolyBase does not offer a fine-grained security solution. It's really not intended for that particular use case. The way that we connect to Azure Blob Storage is with shared access signature tokens. Let me show you how to create one. I am now in Microsoft Azure Storage Explorer. I want to create a shared access signature token to the CS PolyBase Blob storage account, as that's where my data is. To do so, I can right-click on the storage account and then select Get Shared Access Signature. That brings up a dialog with quite a few settings. For my purposes, I'll leave the settings at their defaults. Although if you want a more detailed dive on what these settings mean, I do talk about them in my video on using DVC to store data science artifacts in Azure. I'll leave a link to it below, timestamped to when I start talking about these shared access signature tokens. Because I'm good with the defaults, I'll just select the Create button. This pops up a screen with the SAS token. Let's copy that. And now I can close this window and switch back to Azure Data Studio. I can replace the contents of the identity on line 15 with my SAS token and run lines 1 through 16. The next thing I need is an external data source. This simply tells SQL Server where the remote data is hosted. In this case, it's in Azure Blob Storage, so I can use the prefix ABS to indicate this. It's in my CS PolyBase Blob storage account in a container called ncpop, and I'll use the SAS token we just created to access data inside of there, as it's not a public container, so not everyone can get access to it. Let's run lines 18 through 32 now, and we wait. I will tell you that the occasional delay is sometimes normal with PolyBase, depending on what you're doing and how much data you're moving and how good the network connections are between your SQL Server instance and the source of your data. But if creating an external data source is taking this long, you've got a problem. And a problem we do have. It eventually times out and gives a really nasty TCP error. This, to be clear, is not the expected behavior. What's going on took me a while to diagnose, but it turns out my virtual machine's name is too long. I'll show you the name here. For this Hyper-V based VM, it seems like any server name longer than 15 characters will choke, as PolyBase is trying to connect to a server name using at most the first 15 characters. So then I thought, hey, let's be clever about this. Let's go back to the VM, and we'll open up Etsy hosts. In here, we have an entry with our server name pointing to 127.0.1.1. Let's add another entry going to 127.0.1.1 for the first 15 characters of the server name, which in my case would be testo-virtual-m. I'll make that change here and then save the file, so this way any requests against testo-virtual-m will route locally. So let's switch back to Azure Data Studio and bask in our glory. I'll try creating the external data source again. And what is this? Windows authentication failed? We aren't even using Windows authentication. This isn't even Windows. What's going on here? I banged my head against the wall a bit on this one because the only explanation I found online for this particular error came from Nathan Shonak. But Nathan isn't talking about SQL Server on Linux in his blog post, and his fix there will not work. I am going to give a link to the blog post because if you run into the issue on Windows, yeah, it's a good solution. But ultimately, my solution to this problem was build a new VM with a name shorter than 15 characters. That way, I don't run into the issue. We interrupt this program to bring you an important announcement. Not too long after I complained about this, my friend and official man of knowledge, Anthony Nocentino, kindly and politely told me to RTFM, in the nicest terms, of course. It turns out that SQL Server on Linux does have a limit of 15 characters for the host name, and you can change the value of it in /etsy/hostname. So that is an option if you have a long virtual machine name and don't want to rebuild the whole VM in a peak of fit like I did. So let's switch VMs to one already in progress. I have this other VM called SQL VM 0. Only 6 characters long, so much better suited to our purposes. One thing I'm going to point out is that, for PolyBase on Linux, we need to enable a particular trace flag. This trace flag is kinda sorta documented, in the sense that there's a blog post from Amit Khandelwal that mentions this trace flag. So let's enable it, because otherwise you will have trouble working with blob storage or S3 on SQL Server 2022. Alright, now we're good. This VM also has the benefit of having credentials set up already, so let's make sure that I'm in script 02, and then I'll change the connection to SQL VM 0. Now I can run through the elements of this script much more quickly, as things will actually work. We've already talked about the database scope credential and external data source. Let's rerun these sections to make sure that we have both created on our SQL VM. I already have a SAS token, so the database scope credential won't get recreated, but I will have a new data source as a result of running this script. The next thing we need is an external file format. This is the structure of the data. I'm going to grab a comma-separated values file, so I'll create 2 forms here, one with headers and one without. Now this isn't a video on PolyBase functionality, so I am going to elide over the differences. If you want a more detailed dive on the topic, check out that video I posted and referenced earlier on. And let me know in the comments if you would like a video series on PolyBase. If I do get some people saying that they'd like it, I'll definitely dig into the topic some more and create a proper series on it. Anyhow, the final part is the external table. We're going to point to the blob storage account and look for a file called census/North Carolina population.csv. The file format is our CSV file format with a header, and we're going to accept any query that has 5 or fewer rows with errors. The reason I have this set is there are a few bad rows in my CSV file, so this is a good way of allowing me to get results, even if we have a couple bad apples in the bunch. Let's do the equivalent of select star on this external table, and we get back 13,607 rows. We will also get a few nasty looking error messages, but that's just telling me that 3 rows had bad data for the population column. They had the letter A instead of a real number. I've got plenty of other examples, but let's do just one more to drive the point home. I'll switch over to script 04. This lets me show off the PolyBase ODBC functionality that Microsoft introduces in SQL Server 2019. I've already created a database scope credential called Desktop Credentials. I'm also going to create an external data source called Desktop and route it to an IP address that corresponds with the Ubuntu 22.04 VM that I used in the SSIS video. I've preloaded some data on it, so let's create this data source and keep going. Now we're going to go to script 05. We don't need an external file format because we're using the ODBC connection to reach another SQL Server instance. So I just need an external table. I'll create the table and then quickly query it, and here we go. Data from another machine as though it were local. And that's PolyBase on Linux. It turned out to be a little more of a challenge than I had hoped, but some of that is the weird kind of stuff you just sometimes see in the tech world. Unlike SSIS on Linux, I do like PolyBase on Linux. And it's not just because I have a pre-existing bias toward PolyBase. I do, but that's not the reason. The functionality is pretty much the same as on Windows, and this team has been pretty good about keeping the product up to date. We'll have links and show notes in the description below, and until we see each other in the next video, take care.